Hi, in this video, you will learn about one-dimensional kinematics. I bet you all know what is one-dimensional kinematics, but as a review, kinematics is the description of how things move. One dimension is, well, it's self-explanatory. Basically, it has only one dimension. Combining the two definitions, we get it is a description of how things move in one dimension. And that is the meaning of one-dimensional kinematics. Insert smiley face here. The title of our video is, well, we can name it How to Make Your Dog Follow You for Dummies, but I guess that is a tad bit inappropriate. So, it's named Doing P6 with Man's and Woman's Best Friend instead. That is the title because we took the velocity and acceleration of my dog. By the way, she's named Chacha. So, how did we get my dog to go along with this project? One answer: food. If you look at the video, my dad is, insert quotes here, tricking the dog into following the food, making her walk. And after we got the video, we took the position, velocity, and acceleration time graphs for the video. First, let me explain the position time graph. In the position time graph, the velocity of the dog, as shown, is almost constant, but it still has that curved parts. And yeah, the huge gap before the graph started was because the dog wasn't present in the video yet. So she appeared at about the first 1.4 seconds of the video. The line, which as shown is upward, is because the dog is going to the positive side of the axis, which is the right axis. So the main idea for this graph is that the motion of the dog is not constant in some parts, but constant at some, and she is moving to the right. Next is the velocity of the dog. Yes, it looks kind of weird, but this is because the velocity of the dog is not constant. This is shown in the position time graph with the somewhat curved parts of the graph. So the initial velocity of the dog is at around 69 centimeters per second, and the final velocity is at around 51 centimeters per second. The velocity of the dog at the first frame is that it increased, then decreased, then increased. You get the point. So the main is the dog's velocity changes as well as the slope of the line. That's why it has sudden stops on the line. The velocity, like in the position time graph, was shown to be performed to the right. And lastly, the acceleration time graph. The movement of the dog, according to this graph, is that the acceleration of the dog changes from time to time. At first, the acceleration was at 78.3 centimeters per second squared, and then the final acceleration was at 120 centimeters per second squared. There was no time wherein the acceleration was constant because the plots on the line kept either increasing or decreasing. There was no flat, straight line. Basically, the acceleration of the dog is changing. This is because, like in the velocity time graph, the slope is not the same for all lines. And since the slope of the velocity time graph is equal to the acceleration, then the acceleration is changing. Let's see if what I've said is right. In this experiment, we learned that all three graphs affect each other's data because they are all related in some way. Due to this, we realized that a slight change or modification of a point assignment on tracker could change the graphs. And because of this experiment, we had more exercise on analyzing what the graphs really mean when we were checking if the data displayed on the graphs would match what is shown in the video.